So like it or hate it, but you cannot ignore Project Amber. Started in 2017 at Oracle, the goal of Project Amber is to explore, incubate smaller, productivity-oriented language features. Just in case if that feels a bit complicated, let me simplify that for you. You can think of Project Amber as an umbrella under which various new language features or modification to existing language features is proposed, talked about, debated, worked on, and finally released with a new Java version. This is probably the most important question for the session today. Why should you be caring about Project Amber? This is not an API or a framework which you can ignore. As a Java programmer, Project Amber will change how you read or write your code every day. The main point is every day. Even if you ignore the features which are coming with it to write the code that you write, of course you can choose what you want to, the features that you want to use. But what if you have to read the code which is written by another programmer which uses these features? So, as I said, like it or hate it, but you cannot ignore Project Amber. Just in case if the statement was not scary enough, I have a few examples where you can see how the features which have been released with the recent versions of Java have changed how you write your code. So this is usage of var, which came in Java 10, and how you can ignore using the explicit typed to define your local variables. This is switch expressions. Your humble switch statement can now return values. This was with Java 12 and 13. With Java 13, text blocks is here, which will simplify greatly how you write your multi-line string values without using the concatenation operator and most of the escape sequences. And probably in one of the future versions of Java, you would see how you could write your methods like this. Until now, you have seen the syntax with the Lambda expressions. That is also in plan to come to how you write your methods. And sealed interfaces or the sealed entities would let you limit the classes or the interfaces that can extend your entities. Are there any stages? Yes, there are. Java is an old language. It's more than 20 years. So anything that goes into the language, if it breaks any code, that could be a big problem. So all the features that we are talking about, they go through multiple stages, from draft to proposing to a particular Java version to completion. They go to, through multiple stages just to make sure that what is being proposed works for the language and all the projects that work on it well. And as you can see through these lines, the ones which are in light blue color, at any of the stages, a language feature, a modification or a new language feature can be withdrawn or dropped altogether, depending on the feedback that is received on those features or internally if things don't go the way they were planned to. A lot of features that I would be talking about have already been released in recent Java versions. Some are planned for future releases, but a lot of others also do not have any release dates because Oracle would assign a release date with those features like the concise method bodies that I showed in one of the slides. That would be assigned a Java version when they are ready. I hope all of us would agree with this one statement. Change is constant. Whether we like it or not, it will happen. Change is inevitable. Yes, it will happen. Change is beautiful. How many of us agree with this statement? Most of us, right. But that really depends on how we have to change, how we have to adapt to the change. As Darwin said, it's neither the strongest nor the most intelligent that survives, but the one that is most adaptable to change. So Java is changing, yes, for the better. And what happens when we have to migrate our projects to the new features? Change is painful. Ouch. So how many times do we use that word when we have to make a change? So I'm here to help you adapt to the changes which are coming to Java, because the changes are the least painful when we know what is in store, when we can see what is coming our way, and when, of course, we know bits about the changes, then the change is the least painful. And the small changes which are coming to Java, take them as small gestures of love, kindness, and care that you have in your everyday life that makes your life better. Of course, in small ways, but yes, they do make a difference. So in today's session, I would quickly cover all these features. So we'll start with local variable type inference with var, which helps you to drop the explicit type in the local variables that you write in your code. Before I get on some code, we'll quickly try to understand what type inference is with this puzzle. So given this piece of puzzle, would that be a good fit? No. Would this one be a good fit? Would this one be a good fit? Yes. So you all played compilers right now. So given a set of constraints, you were able to determine what the right block was for this piece of puzzle. So this is exactly what happens with type inference with local variables in Java. The compiler is given a set of constraints in the terms of code that you write, and the compiler gets around those constraints and determines the type of your local variables. So let's have a quick demo here. So let me define a couple of local variables. So I just defined 3 local variables. These are defined with explicit types. So I could change those explicit types with var. But Java is still a statically typed language. So all the types are still known to the compiler. We are not moving to the dynamically typed language. Just for a quick example, you can see this is still the local date time and the compiler knows about it. And again, I could replace that with var. So what happens here? Can I add these values? Yes, this is acceptable. And let me add a string and an integer here. So what happened right now? So let me rewind. So with the code that I just typed, I've put an integer and a string as keys, which I shouldn't have been able to. So let us rewind and see what happened, what went wrong. So this was my original code, but when I changed that to var, I took off the type information from the variable, and what remained was a raw type. And that's why it behaved the way it shouldn't have. But this is something that Java developers knew from the beginning. It's just that when we get to work with a new feature, we kind of assume a lot of things which we shouldn't. So we should be, as developers, we should be good with the basics that we already know. So that's another way of using var. Now I have the type information with the variable. And now if I try to, let's say, add an integer as the key, then it will not work. Now, this is not working now. Oops. So this is a compilation error. Now the other thing is, what happens if I assign, let's say, null to a variable? If I say this is var, then this will not work because the compiler doesn't has all the constraints which helps it to determine the type of the variable. Again, I could not let it uninitialize the way I can do that with my explicit types. So the compiler would not really let a variable in if the type is not assigned or if it's initialized to null. Okay, so the other thing, so what really happened here? So that's another example. So when I talked about the raw types, what I did was I literally chopped off the type information I had with my type and replaced that with var. That doesn't work. So chopping off the type information would not help. That applies to your generics, that applies to collection objects, applies to the arrays as well. So as I said, these are, var can be used only with the local variables. So this is where you can define your local variables. So Java doesn't allow you to use var with your instance variables and your static variables. Just one question. I won't ask a lot for the remaining of the session. Do you think the first line of code will compile? Oh, that's the perfect answer. So the first line will not compile. The second line will compile, and the third line will compile as well. So a lot of time when I ask this question, a lot of programmers say yes to the first line. And this is because, as I said, a lot of assumptions come in when you try to use a new feature. As programmers, we just need to refresh the basics that we already have. So in this case, we are used to kind of using a variable of a parent class to assign it to an instance of the child class. But when you use var to do so, the type would be the child class and not the parent class, because that is resolved during the compilation time. Now the second feature is local variable syntax for Lambda parameters, which came in with Java 11. So we already had local variable inference for type inference for the Lambda parameters that we already used. So if I say, I can see that this is integer and which is already inferred by the compiler. So why do we need the var here? Because if for this code, I cannot use the annotations. And the other point is to align it with the usage of var with the local variables. And just for your information, even though we are used to writing the Lambda parameters in different ways, these all are the same. And when I use either var or the explicit type with my Lambda parameter, I can use annotations like this. So this is one of the main benefits of using var with Lambda parameters. Now we come to the switch expressions, which was released in Java 12 as a preview language feature. So Oracle introduced the concept of preview language features with switch expressions. Since it moved to a new release cadence, which was a 6 months release cadence, so it needed some time to get the feedback from the developers and to make sure that all the enhancements, improvements, or additions that they have with a language feature are the right ones and there are no issues with it. Because unlike an API which can be deprecated if it's not in use, or if Oracle thinks that, of course, we are having a better version, the language changes. Once they go in the language, they cannot be taken off. So Java 12 switch expressions was introduced as a preview language feature. These are not incomplete features. They are for developers to work on. Of course, it's not recommended to use them in production because they might change in the future releases, depending on how it goes with the developers. So let's have a quick demo here. So this is how you would use your switch statement. It has an assignment statement. We have a break statement so that the control doesn't fall through the next line of code. And usually we use it to assign values. Of course, we also do it to do a lot of other things. Now, what has changed with switch expressions? Now, switch expressions would allow you to use switch statements as something as to assign values to your variables, or use them the way you have been using them always. So I could replace that with the switch expressions. Of course, I could code that as well, but this is how it has changed. And if I have two values which are the values which are returned are same, I could also have multiple case labels in the same switch branch. And since this switch expression is returning a value, the values which are taken care of by the switch branches, they should be exhaustive. What happens if it's not? So first of all, let me remove the default label here. Now, because this is an enum, all the values are being taken care of here. What happens if I remove another one? Now, in this case, it will not compile. The two solutions that I have is either to insert a default label, or, of course, to have the same statement which I deleted. The reason is when we're talking about returning value from a block which is used to assign another variable, the values should be exhaustive. So this is an enum. What happens to types like string, int, which do not have exhaustive values? In that case, if I'm using a switch expression to assign a value, then it must use a default label. And this is not all. Of course, you can use it to define a code block as well. You could say int age is equal to 10. But how do you return a value here? You can use a yield statement. So this has changed with Java 13. In Java 12, switch expressions used break to return a value, but because of the feedback received from the developers that break was being confused with the break statement, which we are used to using in other scenarios, it was replaced with yield in Java 13. Of course, you can still continue to use the regular switch statement. So we talked about returning values versus executing statements. You can also use blocks to execute your statements. We talked about the exhaustive cases, the default fall through of control, which you don't need with the enhanced switch expressions. So now let's talk about the text blocks. Okay, so strings are like babies. They look cute when they're small. So what happens if you're talking? So what happens if we talk about, let's say, a big string? So I could code it like this. Looks cute, right? With a lot of concatenation operators. So let's make it a bit more complex. So what happens if I have to, let's say, define a JSON object as a string? I can say string JSON is equal to, and this looks cute again, right? Yes, of course, it's a bit difficult to modify, but still. So what is happening with text blocks? Now, you don't really have to bother with so many concatenation operators and the escape sequences. So this is how you could use text blocks. So the one which is referred by JSON2 is a text block. It has 3 double quotes as the opening and closing delimiters. And of course, as you can compare these two values, you don't need the concatenation operators and the escape sequences. So what happens to the incidental white spaces that you have in text blocks? So you usually align your text vertically in inserting a lot of spaces. So are these part of your text block or are they not? So if you are using IntelliJ, then you could see a green vertical bar here, which would actually show the content of your text block. The closing delimiter also specifies how many white spaces you want to include in your value. It's either the closing delimiter or the first non-white space character of your string value. Of course, with this text blocks, Java has also added a couple of methods which you can use to format your text blocks, which include concatenation with your variables. So we've already covered this one. So the features that I just discussed have already been delivered with the recent versions of Java. Now I'll quickly talk about some of the features which are in line to be delivered. 2 are most probably would be out with Java 14, which is records and pattern matching. We're not sure yet because they proposed to target with Java 14. That means probably yes or no. So this is, I've used this image to show that what we have been taught ever since we started programming in Java is that one size fits all. You can use your classes to define everything from enums to regular classes to data classes, everything. But no, that really doesn't how it works. One size doesn't fit all, and we really need different type of classes to do our work. So what happens, let's say if you want to define an employee class, let's say it has just 2 fields, which is name and age. What do you do to store it to your database? So ever since we have been kind of instructed to have a lot of getters, setters, be a good programmer, define the toString method, override the toString method, and be again a good programmer and override the hash code and the equals method. And this is what we do. We either generate them or we write them by ourselves. So this is how you could quickly generate all your code. And so we've generated a lot of code for these 2 fields just because we want to save these 2 fields for the employee type in our databases, or we want to send them to, let's say, a remote server. Of course, the IDE can help you generate all the code, but what happens when you have to read the code? I could easily modify any of the value here. What happens? As a programmer, when you read the code, you still have to browse through all of this to figure out whether it's the default code or something which has been changed. With the records, you would be able to define all that functionality using just one line of code. I'm wondering what Google would use in their keynote next year, because this is what they used against Java last year. Of course, this is again syntactic sugar. Behind the scenes, the compiler compiles your records to a full-fledged class. And this link includes a lot of details on records, so probably you can take a look. Now we're talking about the sealed types. This interface, when defined using the keyword seal, would limit the classes or the interfaces that can extend or implement your classes and interfaces. That applies. So in this case, we're talking about an interface which can limit these classes and interfaces. This is still in works. So this is okay, so I move to the other topic, which is concise method bodies. So this is how you have been used to defining your methods. We're talking about one-liner methods here. And with concise method bodies, you would be able to use the Lambda syntax to define a method. Now I'll talk about pattern matching. So how many of us just hate such code? Yes, me too. And how many of us have to count the round braces we have to put? Okay, we all are using, oh yes. I absolutely hate this code, because what is happening here is when you test whether an instance is a type of another type, class, what is the next step? The next step is to cast it and then to extract the values from it. So why something which is so obvious has to be done by the programmers, and why can't the language do that? Okay, so Oracle is listening, and this is, of course, that's another way of writing the same code. And this is how, with pattern matching, you would be able to introduce a variable so that once the test passes, your instance would be attached to it, and then you wouldn't need the type explicit casting. Of course, if the test fails, then you would not be able to use the variable ocean. As you can see in the else block, that would not be accessible. It would only be accessible in the if part of this testing. So this is just a quick comparison on how it helps you as a programmer. So we talk about enhanced enums. So enhanced enums, as of now, is on hold due to multiple issues that have been in the way of taking it to the finish line. So this is how we all define our enums. One quick example, we have enum size, small, medium, large. Has anyone tried to define members, which is variables or methods, to specific enum constants? Because this is, the code in red defines members, which is specific to the enum constant medium. Of course, the rest of the code defines the other members, which is the variables and methods, which applies to all the enum constants, but the ones in red are only specific to medium. But the problem here is, even though you can define those members, you cannot access them. If you try to do that, you would get a compilation error. This is because the compiler can't really see those enum member specific variables and methods. So this is as good as extending a class where you don't get the name of the class, so you really can't refer to that extended class. Have any of us tried to view the compiled classes that we see? And if you have an anonymous class, you get to see something like class name $1, something like that. Yes, a few of us. So that you can compare this to that one. With enhanced enums, you would be also able to use generics. You would be able to define something like the one that you can see right now. And this is how you could use those enhanced enums. Probably form data which could use your enums like this. So we come to the end of the session, and if there's one thing that you would take away from the session today would be the change is constant. Oracle is moving Java forward faster, and I would recommend and encourage all of you to use those features. Even if you're not using them right now, you probably would have to migrate your code bases to the new versions. So please use the features. That would really help you to migrate your projects later. Thank you very much.